My name is Evagelos Varthis. I do my PhD in Ionian University in Greece, and the title of my presentation is Implementation of Databaseless Web REST API for the Unstructured Text of Mignis Patrologia Graitsa with searching capabilities and additional semantic and syntactic expandability. The title is a little long, but the system or the study wants to provide a searching service on large corpora on the web domain. In fact, we take all the unstructured texts and convert them to a set of JSON files which they form a web REST API. So here we see the skeleton of our presentation. It has 4 parts. In the first part, we'll talk about what is Patrologia Graitsa, little words, comparison of relation database systems and NoSQL systems. We do this comparison because our system converts the texts into a similar to a NoSQL database. In the third part, we describe our system. We talk about the transformation process and, in general, the overall REST API architecture. In the fourth part, we talk about the extensions and the future of our work. So what is Patrologia Graitsa? It's a very large collection. It has 166 volumes bound as 161, and in fact contains 120,000 pages. This large collection has mostly works by East Christian fathers for the period of 14th centuries, from the 1st century until the 14th century. Contains vast amount of information related to philosophy, psychology, theology, music, politics, and everyday life. In general, there is a lack of systems that search large corpora on the web domain. The only organization that dealt with the Patrologia Graitsa is TLG, that converted the texts about roughly 20% in textual form, and the Preserves library, however, is less comprehensive, and there is not searching in general. TLG offers searching through with the private use of a program called Museos. What motivated us to build such a system? In fact, the questions how to find the fragments of large collection. It's not easy to do that on the web domain directly. The common practice is to download the collection and write a program to search for word terms or to make further analysis. Who is interested in such kind of service? I mean, to download the collection. Only specific researchers that focus on the field of natural language processing. We believe that searching the large corpora on the web domain will benefit everyone, scholars, researchers, and simple users. In this part, we will talk a little about what are the options to search on large corpora. In fact, we need, if someone wants to build such system, he will use relation databases or NoSQL databases. Some kind of relation databases are Oracle, Microsoft SQL, or NoSQL databases. Some kinds are MongoDB and DynamoDB, and etc. There are main differences between this kind of database systems. This is a comparative table. Relation database system have specific structure in the data that they have storage or they contain, while NoSQL is more free to how store the data. Also, NoSQL systems are more or horizontally scalable. I mean, higher traffic, you can split the database on more computers and have better response to larger queries, etc. The same is not easily maintained with relation databases. Also, the cost for maintaining and building relation databases is higher than NoSQL databases. What is our system? In fact, our system auto-transforms the textual data to a similar to a NoSQL databases however with completely static nature. As I said before, we take the unstructured texts and we convert them to JSON files. No people to intervene for the transformation or input the textual data. The final system consists of a set of JSON files. In fact, these JSON files represent objects, and they are served only by web server or S3 storage. S3 storage is a very cheap storage introduced by Amazon, and in fact, for example, 500 gigabytes costs only €5, for example. Our system doesn't need any maintenance also. Some benefits are simplicity, fast searching, scalability, accessibility, easy replication of the system, independence of the user interface, no need for special line management, in general, costless. I would say here, very cheap. In fact, nothing. The main transformation is we take the unstructured works, and we have 3 stages: building fragment files, building Word files, building stem files. And after the transformation, this set of files consist the web REST API. We'll talk in detail. In the first stage, we're splitting its work in a set of JSON fragment files. These fragment files can be a paragraph, a specific number of text lines, or a specific number of words. The second stage is creating the Word files. What is the Word files? Are JSON files with file name, the name of the searching word. This Word file contains the links to the JSON fragment files that contain the searching word. We'll show that later in more detail. Creating a set of 2-letter stem files from the set of the Word files. This is files that it's mostly for the user to search easily on the web domain. So this is the first stage. We take a document and we split it here in the same number of lines. So we create 5 fragments. This is the JSON format of the fragment file. We have some information here, for example, the fragment D, the fragment content, and some more, for example, the author name that this fragment belongs, or the word title. Also for navigation, the first fragment of the work, the next, the last, etc. And all this is done automatically. The second stage is to create the word fragment, the word files. For each fragment, we take the unique words and we create these files that have the file name of the word. Inside, in each of these files, there are the links to the fragments that contain this word. For example, gar, which means Y in English, contains fragment 1, 4, and 5, because in these fragments, this word is contained. This is the result of the JSON file. We just have blocks of the links with some additional information with author name, work title, etc. And the third stage of the system is to create the stem files. These stem files are created by the Word files we have already created, and in fact, they are files that they have 2 letters as a name. Each of these files contains all the words that starting with the same, this stem of the 2 letters. Why we do that? Because searching with a web browser would be unfocused for the user. The user doesn't know which words there are in the corpus. So just writing two letters presents all the words that are related to this 2-letter stem. It's just a list. This stem file is just a list with the words that begin, for example, here with na. This is how the transformation is created. Here, there are, in fact, the REST API resources that we get. We have a working example. I will show it later, the prototype tool we have built. For example, the first resources, API, words, Narcisse. What is that? Give us a list with the links of the fragment that contains the specific word which is presented. The second API resource is list, API list, NI alpha, for example. And we get the list with the words that begin with the two-letter stem, as was presented. In the third REST API resource, we get just the fragment. The actual text fragment is presented when in the browser we put this link. All these resources can be modified and searched via JavaScript or other language via the web browser. This is the overall REST API architecture. For example, we have the client, a client application that communicates with the web server, and the web server has as response the fragment files, the word files, and the stem files. So we can build, in fact, any client application completely independently by the backbone of our system. It's worth to know that before, in front of the web server, we can also put a content delivery network, CDN service, in fact, to cache all the results. So any amount of users can easily search without overloading the system or without needing any loading balancing for the system. Here's the web browser-based interface we have built. The user types 2 letters and get the list of the stem files, the words that exist in the corpus. Clicking on the word, we get the fragments. Clicking on the fragments, we get the actual fragment of interest. Here's the screen of our tool. We put 2 letters in the input box, and we get all the lists of the words that begin with these 2 letters. Clicking one letter here, we clicked Narsin. We get all the fragments in the middle that contains from 5 million words, which fragment contains this word. Clicking on in the middle links, we get on the right the fragment, and we can navigate to the fragments, next, previous, or we can see the complete work. This is, of course, a prototype. Extensions and future work. What extensions can be done for this system? Searching for more than one word, it is easy to implement this extension. Searching individually on various corpora using the same interface is also easy to implement. Searching concurrently on various corpora using the same interface. Simplified searching enrichment at word level. Or citation service for fragments. For example, if a scholar wants to write a book or to have reference to Pathologia Gratia with, and to locate a specific fragment, this kind of service will help him, because now, at the moment, there is not such possibility for any scholar to do that. Future work and extensions that are more difficult to be implemented is a syntactic enrichment and semantic enrichment. Racking the results that we get when we are searching with more than one word, and terminal-based processing of the system. I will say about little things about searching for more than one word. How this is accomplished. For example, when we searching one word, we get the links, the fragment links. So having here 3 links, we don't search the words. We search the fragments that we get from the web interface. In this kind of this situation, these words, these 3 words, on the same time exist on the fragment 5, because it's the common fragment that these words have. So this is the technique to search, let's say, for more than one word. Searching individually on various corpora, we just change the base URL. If we want to search for Homer text, we just build the Homer text, we convert them, and we just change the base URL. Searching concurrently in various corpora, it is also possible concurrently to get the links from the Homer text or from Pathologia Gratia. Simplified searching, semantic interconnection at word level. Okay, this is something very easy to be done. For example, to the text, to the fragment text, we can make all the words clickable, so all the system to search without searching in the input box. Citation service, because every fragment has a unique query. So everyone that wants to share this fragment of interest can easily done. Future work. Future work. Syntactic and semantic enrichment. Independently of our system, we can add in the future more two resources. For example, API syntactic narcisse and API semantic narcisse. The syntactic extensions gives the grammatical forms, for example, for a specific word, and this can be accessed directly from the internet. Also, the same is applied for semantic enrichment of the corpora, of the corpus. What is narcisse, for example, is person, profession, military general, nationality, Armenian. All this information it is, how can I say, easy to be input in the system, but needs details design. The syntactic extension acts in similar way as the tree banks, describes the grammatical forms, lemma, synonyms. The semantic extension describes entities, person, places, cities. Also can interconnect resources related to the fragments to enrich the text. For example, the scan text of Patrologia Grazia with the textual data or the corresponding comments. Okay, this is left for a future communication. Also, it is possible when we search for more than 2 words to apply ranking, to rank the results. This is not so easy, so difficult to be done because, for example, if you want to apply the vector space model, the term frequencies and invert document frequencies is easily to be computed during the transformation. This is considered strongly for future implementation. Also, another extension that it's worth to be done is to search this system or similar systems, if they are applied to other corpora, from command line, for example, from a Linux terminal. Various software tools can be built, but we like the simplicity, for example, of Amazon command line tool when searches the S3 storage. In our paper, there is some examples how to access, for example, the backbone of the system from Linux terminal. This is also considered for future communication. This is the end. I would like to show the prototype tool. I don't know.
Maybe 1 minute, that's possible?
Yeah.
1 minute?
Wow, I have 1 minute. Yes, okay. So this is our system. For example, we write 2 words and directly the list of all the words. If I could write, for example, Greek in this computer, writing R would narrow the result. A filter would apply directly to narrow the results. It's not... okay, we choose 1 word, for example, directly the fragment disappeared. Or here. Clicking the fragment, we go to the fragment. The name is bold, just for the user to see. We can go next to the next fragment of the work or the previous fragment. We can search, or we can go to the complete work. This is the link for citation service if the user wants to directly offer this fragment to any other people. So this is the presentation. Thank you very much.
Thank you.
Okay.
Yeah, maybe one question again. Anyone? Maybe if I can ask, so the fragments, the JSON files,
yes.
All of them, are they all pre-created or do we create them on the fly also?
They are created. We convert the text to direct to fragment files. This is a conversion process. This last maybe some hours for the text, for this specific text to be done. However, when we convert these JSON files, the system is ready for such kind of searching. Okay.
Thank you.
Thank you.